So what's the ultimate goal of science? I mean, what is it really trying to do? Is it painting a true picture of reality, uncovering its deepest secrets? Or is it just building better and better tools to help us predict and, control the world around us? This is a huge question, and it's not actually a scientific one. It's one of the biggest philosophical fights about science itself.
Okay, let me put it this way. Are atoms real? Like, really real? Are they actually out there, little things zipping around exactly how our textbooks say they are? Or are they just really, really useful fictions? Convenient ideas we came up with that just so happen to make all our math work out for chemistry and electronics. This one question, right here, is the absolute core of the battle between what we call scientific realism and anti-realism.
All right, first up, let's talk about the default view. This is the one most of us, I think, just naturally believe. It's called scientific realism.
So if you're a scientific realist, you're basically an optimist about science. You believe that when a scientific theory is super successful, like our theories about atoms or DNA, it's successful for a very simple reason. It's actually describing something real. It's not just a good story, it's more like a map of a reality that exists completely outside of our own minds. And the whole point of science from this perspective is just to keep making that map better and more detailed over time.
But, of course, there's another side to this coin. And here comes the challenger, the more skeptical voice in the room, scientific anti-realism.
Now, this is absolutely crucial. Nobody, and I mean nobody, is arguing that science doesn't work. Of course it works. The whole debate is about why it works. The realist says it works because it's true. Simple. But the anti-realist comes back with, no, it works because it's empirically adequate. All that means is that it's just really, really good at predicting the stuff we can actually see and measure. For them, asking if a theory is true is kind of missing the point. It's a great tool, and that's all that matters.
And this disagreement, it runs deep. I mean, it's a fight on 3 different fronts. First, there's the metaphysical level. That's about what's real. The realist says, yep, there's a real world out there, whether we're here or not. The anti-realist, they're a bit more hesitant, maybe even agnostic. Then there's the semantic level. That's about what our words mean. When a realist says electron, they mean a literal little particle. The anti-realist might say, it's a useful word in an equation. And finally, the epistemological level, what we can know. Realists are confident we can know about things we can't see. Anti-realists say, whoa, hold on, we should really only be confident about what we can actually observe.
Okay, we've met the fighters. Now it's time for the main event. Let's look at the absolute best, most powerful argument each side brings to the table. So for the realists, their heavyweight champion is something called the no miracles argument. And it's pretty powerful. The thinking goes like this. Science is just ridiculously good at making predictions, right? I mean, predicting things that nobody had even dreamed of looking for. And for a realist, if our theories were totally false, that kind of success would be, well, a straight-up miracle. It's just too much of a coincidence. So they say the best explanation, the only seen explanation, is that our theories are at least approximately true. They've got to be latching on to something real. But the anti-realist has a killer counterpunch. It's called the Pessimistic Meta-Induction, which sounds complicated, but the idea is simple. They just point to the history of science and say, look at that. It's a graveyard. It's filled with theories that were once the best thing we had, super successful theories, like the idea that heat was a fluid called caloric, or that light moved through a substance called the ether. These theories worked. They made good predictions. And now, we think they're completely wrong. So the anti-realist asks a devastating question. What makes us so special? Why should we believe that our current theories aren't destined for that same graveyard? And they're not done yet. The anti-realist has another argument up their sleeve, underdetermination. The basic idea here is that the evidence by itself is never enough. Just think about it. If I give you a handful of data points, right, just dots on a graph, how many different lines or curves could you draw that pass through all of them perfectly? Potentially an infinite number. Well, the same goes for science. For any set of evidence, you can often come up with a bunch of totally different theories that all explain it perfectly. So if the data fits all of them, how on earth could we ever know we've picked the one true one?
Okay, I know this is all getting a bit philosophical and abstract, so let's bring it back down to earth. Let's put science on the stand and see how this debate actually plays out in the real world, in different scientific fields. Let's start with a place where realism seems like a total slam dunk, paleontology. I mean, come on. When a paleontologist digs up a gigantic T-Rex femur, it's pretty hard to argue that a T-Rex is just a useful story to explain bone patterns. You can literally hold the evidence in your hands. It's big, it's heavy, it's real. And that's why realism feels so right, so intuitive in sciences like this, geology, anatomy, places where the stuff you're studying is right there in front of you. But now, let's flip the script completely. Let's jump to the other extreme of science, to the weirdest, most successful, and most mind-bending theory we've ever come up with. Welcome to the anti-realists' home turf, quantum mechanics. Seriously, the world that quantum mechanics describes is just bonkers. You've got particles that are in multiple places at the same time. You've got spooky action at a distance. It's so fundamentally weird that a ton of physicists basically throw up their hands and take an anti-realist position. Their attitude is often, look, don't ask me what a wave function is. I have no idea what's really going on down there, but I do know that if I use this equation, I can predict the result of my experiment with incredible accuracy. That whole approach has a nickname, shut up and calculate. And that is textbook anti-realism. It's all about the tool, not the truth.
And you see this kind of thinking pop up all over the place, especially in the more theoretical sciences. Like, is the multiverse a real thing with countless other universes out there? Or is it just a weird side effect of the math we're using? What about the rational actor in economic models? Is that a real description of how people behave? Or just a handy, simplified model that helps make predictions? When you get into these areas that are built on super abstract or unobservable ideas, that anti-realist skepticism starts to look pretty darn reasonable.
So it feels like we're stuck, right? It's either team realist or team anti-realist. But like with a lot of these big philosophical fights, maybe it's not so black and white. People have come up with some clever ways to find a middle ground.
Let's look at two of the most popular ones. First, there's entity realism. An entity realist would say something like, okay, maybe our grand theory about electrons is all wrong, I don't know, but I can build a machine that shoots a beam of them. If I can manipulate them, if I can spray them, then the things themselves, the electrons, have got to be real. Then you have structural realism. This is a different approach. A structural realist would say, look, our ideas about what things are, like what an electron is, they come and go. But the mathematical relationships, the structure of the theory, that often sticks around even when the theories change. So maybe that's what's real, the math, not our stories about the things.
All right, at this point you might be thinking, okay, this is kind of neat, but so what? Does this actually matter for anyone who isn't a professional philosopher? And the answer is absolutely 100% yes. Because which side you lean towards here fundamentally changes what you think science is. It defines its goals, its limits, its entire purpose. Is science this grand, noble quest for the ultimate truth, a mission to uncover the deep structure of reality itself? Or is it something more practical? Is it just a human project to build the best possible toolkit for predicting and controlling our environment, without ever really knowing if our tools reflect what's really there? This debate, it's about the very soul of the scientific enterprise.
So I'm going to leave you with that. When you look at all of science, everything we discovered, what do you see? Do you see a map of reality, one that's getting more and more accurate with every discovery? Or do you see a user's manual? Maybe the most incredible, powerful, and predictive user's manual ever written, but a user's manual nonetheless. There's no easy answer here, but it's a really important question to ask yourself.